Okay, so at this point of my original video, I went on to eventually get the solution to this proof, first by lining up the left-hand side items with the right-hand side items of this equation, kind of stumbling at the point where I had the same solution for A and B and C and D, and then used the technique of multiplying everything by -1 to then get an alternative set of solutions, and then mixing and matching between them to eventually get to the end of the proof. And whilst I think that is a valid approach to take, I want to run you through this alternative simply because it's more elegant and much quicker, and probably I would say a more robust way to go about doing this proof. So I'll just get straight into it, and I pick up at this point because this is the critical juncture where in my original video I went down a path, but here with one slight little tweak I can get to the ultimate goal much quicker. And that slight tweak is to knowing that I need unique solutions for A, B, C, and D, and knowing that I'm going to line up the left-hand side items with the right-hand side items, then actually it makes sense to have all of these four numbers be unique, because if they're all unique to start with, then we're going to get unique solutions for A, B, C, and D. And the way we can do that, while still getting back to 4, is multiplying two of these items by -1 so that the negatives cancel each other out. So we can get equal to 2 times -2 times 1 times -1. So you see, I still get back to 4, and I've still broken out the number 4 into 4 separate items to match the 4 items on the left-hand side. But these negatives means that I'm now dealing with 4 unique integers, 4 unique numbers. And so that's going to let us get to the end goal much more quickly. So now let's do this step where we line everything up. So we'll get x minus a is equal to 2, and that then lets us get to a is equal to x minus 2. So I just brought the a over here and then the 2 over here. We'll get x minus b is equal to -2, and that will then let us get b equal to x plus 2. We'll get x minus c is equal to 1, which gives us c is equal to x minus 1. And we'll get x minus d is equal to -1, and that will give us d is equal to x plus 1. Now at this point, if I then say, well, what does that mean when we ask for a plus b plus c plus d? That gives us x minus 2 plus x plus 2 plus x minus 1 plus x plus 1. And in a very similar fashion to my original video, we see the -2 and the +2 cancels, the -1 and the +1 cancels. We get to 4x, which means when we rearrange for x, we get x is equal to a plus b plus c plus d on 4, leading us to the solution that we needed. So I wanted to share this alternative approach because it's far more elegant, it's far more robust. It probably makes more sense because you're starting off with 4 unique values for your 4 items. And there's no need for these 2 separate approaches and then kind of selecting bits from each of them. So hopefully that all makes sense and you found that helpful. And tick boom.